All right, so now we're killing it. Let's kill this C and let's get this section B done with, okay? So here they're saying, okay, they've given us the table and they want us to calculate the rate of reaction. So basically, we know that first we need to make the rate low, and it says rate is equal to K times the concentration of the two reactants, which is this. So CH3, CH3OH, and then multiplying here, we have C6, then H5, then 3, then CCl, okay? Concentration. So this is to the power of M, this will be to the power of N. Now we need to find the powers. That's basically what we got to do. And to find the powers, we go to our table. We need to pick two concentrations, two experiments, okay, for each guy, where only his concentration changes and the other one doesn't. But before we see a lot, we see that this table has way too many things. We needed to have only 3 columns. Why does it have more than 3? It's because it doesn't have rate. It doesn't have the initial rate. It has the change in time, and here it has the concentration of this guy. His initial, okay, you see 0 is for initial, and his final. And we know that the rate is just the change in concentration over the change in time, okay? So basically, we'll be saying our rate is going to be change in concentration. You see, he's from 0 to this. So that means it will be just this final minus 0, which is just this final. So that means our rate would be this over this, right? That will be our rate for experiment 2. So let's first find the rate, okay? So I'm going to say rate 1 is going to be, let's put rate 1. Rate for experiment 1 is going to be 0.00026 divided by 2, okay? And it's going to be here, this is molar, and divided by 2 minutes. Okay, 0.00026 molar divided by 2. Let's do 0.000, then say 26 divided by 2. 0.00013. So go to 0.00013 molar per minute, right? Should I say this is going to be 1, 2, 3, 4. 1.3 times 10 to the negative 4 molar per minute. That's going to be this rate. Then rate 2 for experiment 2 is going to be 0.00065 divided by 2 minutes. Okay, this is going to be molar divided by 2.5. It's now divided by 2.5 minutes. That's the change in time. It's 2.5. 0.00065 divided by 2.5. So it's going 0.00065 divided by 2.5. It becomes 0.00026. It's going to be 0.00026. Okay, and this would be molar per minute, which is going to be 2.6 times 10 to the 1, 2, 3, 4 times 10 to the negative 4 molar per minute. And then you go to rate 3, it is going to be 0.000 here is now 0.00 only 00156 divided by 1.5. What is this? So 0.00156 divided by 1.5. What do I get? 0.00104. So 0.00104, which is equal to 1.04 times 10 to the 1, 2, 3 times 10 to the negative 3 molar per minute. There we go. Here we have our rates. So now I'm going to say for CH3OH, use experiments. Going to use experiments. I want for this guy, only him should change. So I can see in 2 and 3, he's changing from 0.10 to 0.20, but The other guy is not changing, the other reactant. So basically, I'm going to use him. So I'm going to say use experiments 1 and 2. So let's go. What are we going to say? The initial concentration in experiment 2, 0.20, divided by that in experiment 1, 0.10, to the power of m is equal to the rate in experiment 3. Remember, it's 3 over 2. So rate 3 is going to be 1.04 times 10 to the negative 3. Okay, moles per minute, divided by this rate, the rate 2, which is 2.6. Okay, 2.6 times 10 to the negative 4. So it's going to be 2.6 times 10 to the negative 4 molar per minute. Okay, and what is it going to be here? This is going to be 2 to the power of m is equal. So here it's going to be 2 to the power of m, because on the other side I'm going to have this one divided by 0.6 exponent negative 4. I'll get 4 on this side. Wow, now it's great and great. So 2 to the power of m is equal to 4 is 2 squared. You can know that m is equal to 2. Great job. Great job. Now let's go to say 4. Now let's do for the other guy. For concentration of, I'll say, C. We don't have to say concentration. We want the power. So I can say for C6H5 3 CCl, I would say use experiments, which two where this one changes and the other one doesn't. I can say 1 to 2 he changes. Does this one change 1 to 2? No, he doesn't. So I'll use 1 and 2. Use experiments 1 and 2. So let's go for it. I'm going to say the concentration of 2. So I'm going to say the concentration in 2, 0.10, divided by his concentration in 1, 0.05, to the power of n is equal to the rate in 2. What is the rate in 2 divided by the rate in 1? So rate in 2, 2.6 times 10 to the negative 4. 2.6 times 10 to the negative 4. Is it moles per minute? Molar per minute. 2.6 times 10 to the negative 4 molar per minute, over 1.3 times 10 to the negative 4 molar per minute, over, oh my gosh, I'm sorry, wow, it's over 1.3 times 10 to the negative 4 molar per minute. But even if we fight us, we are doing good. So what is this? This is going to be 2 to the power of n is equal to, this is again 2 to the power of, it's just equal to 2. So that means n is equal to 1. Okay. And therefore I can get the rate law. So it's going to be rate is equal to K multiplying the concentration of CH3OH to the power of 2 times the concentration of C6H5 3 CCl. This is to the power of 1. So it's just like this. And this is going to be, that is I'm done. The rates, they said calculate. Oh, calculate the rates. That's the first part. So we already did it. I mean, we did it. Amazing. That's I. Then the second one is the one which now wanted the rate law. So for part 2, we'd say I. Okay, the one where we got the rate law. And then we've done it. Now part 3 is saying determine the rate constant. So anyway, let's go. So rate constant would say K. We'll take these guys to the other side. So it's say rate is equal to, you can first show K multiplying CH3OH squared multiplying, in here it's C6H5 cubed CCl. Okay, and we take them to the other side. So rate over O over CH3OH squared, okay, multiplying concentration of C6H5 cubed times CCl. Okay, this is going to be equal to K. Now we are going to put, what is the rate? What is the rate? Let's just choose 1. In experiment 1, what is the rate? In experiment 1, 1.3 times 10 to the negative 4 moles per minute. So it's going to be 1.3 times 10 to the negative 4 moles per minute divided by the concentration of CH3, we just take it. It's going to be 0.10 in experiment 1, right? And then this is going to be squared times the experiment, the 0.05. Okay, and this is going to be equal to K. So I would say open bracket 1.3 exp negative 4 close bracket divided by open bracket 0.10 squared times 0.05 close bracket is equal to 0.26. So 0.26, and remember here I have in the denominator 0.10 molar squared then times molar. So in here this is going to be again molar here, molar, and I know that this molar cancels with this. I'll remain with molar squared in the denominator, so m to the negative 2 then minutes to the minus 1. This is going to be equal to K, and I have my rate constant, and I'm done. Bravo!